Hello class, today we are looking at what makes a function one-to-one, and we are looking at inverses. So my essential question, how do I find the inverse of a one-to-one function? My learning intention, I am learning to identify functions, one-to-one functions, and their inverses. So the warm-up is based off of prior knowledge. Please pause the video now and see if you can solve these three problems. Well, I hope you try it on your own, because if you are able to solve, that means you are starting to understand the concepts. So how does this work? Let's look and let's think. H, that tells me which one of these three up here I'm using. Well, this is what I'm using. 2x squared plus 5x plus 6. But in place of x, I put a -2. So this will be 2 times -2 squared plus 5 times -2 plus 6. Okay, this is 4. So it's 2 times 4 plus 5 times -2 is -10 plus 6. 2 times 4 is 8. 8 plus -10 is -2. -2 plus 6 is 4. So when I put -2 in, I get 4 as my output. Okay, let's look at the next one. The next one, we talked about the fact what happens when we put 0 in for x. What happens when we put 0 in for x? We're looking for the expression t. This is my expression t. 2x plus 7. So now I'm going to put in 0. 2 times 0 plus 7. 0 plus 7 gives me 7. So this one is 7. So when I put 0 in for x in my function t, my output is 7. And finally, which is the last one we're going to use, the only one we've not used yet? J evaluated at x is equal to -3 times x. But I know that x is -6. So -3 times -6 gives me +18. When I take my function j and evaluate it with -6, I get the number 18 as my output. So we've been working on functions. We looked at how to evaluate them. Now we're going to look at what a function is, and what a one-to-one function is, and how to find the inverse. So a function is a relation in which each input is paired with exactly one output. If you're looking at a graph, it will pass the vertical line test. So when you're looking at any set of numbers, your x value cannot repeat, or it's simply a function, it's simply a relation and not a function. Okay, so a one-to-one function works both ways. You got each input, it's a function, so each input goes to one output, in which each output is paired exactly with only one input. So for each x, there is only one y. For each y, there is only one x. So as we're looking at this, step 1, identify whether they are functions. Are they functions? Well, I will look and think and get that figured out. So what I'm looking at for the function alone, is that first letter, or first number here. Okay, -1, -2, 3, -4, and 8. It is a function because x does not repeat. So simply to be a function, you're just going to look at those first letters. Okay, is it 1 to 1? Now we're going to look and see if if the y values repeat. We got 5, 8, 1, 5, and 8. No, it's not 1 to 1 because of 5, which is here and here, and 8, which is here and here. So it is not 1 to 1. Because all I have to do is one example. -1 is mapped to 5. -4 is mapped to 5. Because I've got the y value repeating, it is not 1 to 1. It is a function because x does not repeat, but it is not a 1 to 1 function because y does repeat. Okay. As I am looking at my inputs, is it a function? I've got 2, 4, 5, 6, 7. It is a function. Okay, so I'm just going to say function because we know what it means. Let's look at the other one. I've got 3, 1, 2, 4, 5. And it is 1 to 1. My y does not repeat. Okay, this means 1 to 1. For the next two, we actually have to do a little bit of math. We're going to replace x with -2. 2 times -2 is -4. -4 plus 6 is 2. 2 times -1 is -2. -2 plus 6 is +4. I put 0 in. 2 times 0 is 0 plus 6 is 6. Can you see a pattern emerging? 2, 4, 6. Guess what the next number would be? 2 times 1 is 2 plus 6 is 8. 2, 4, 6, 8. What's the next number? It's the same pattern. This is a linear function. It would be 10. 2 times 2 is 4. 4 plus 6 is 10. -2, -1, 0, 1, 2. So it is a function. Okay, 2, 4, 6, 8, 10. It is 1 to 1. Okay, so this is a linear. This is a straight line. Remember how we talked it will pass the vertical and the horizontal line test? So if I've got my line going here, here's my vertical line test. It'll pass that. And it will also pass that horizontal line test. So if you're looking at the graph, you'll look at the points. We know it's a function because it passes both vertical and horizontal line test. What if we have a quadratic? Picture in your mind, what does a quadratic look like? If I'm thinking about a quadratic, it has a special shape. We call it the parabola shape. Think about which it would pass. Would it pass a vertical line test and also a horizontal line test? Let's find out. Okay, negative 2 squared. So negative 2 times negative 2 squared. Negative 2 times positive 4 is negative 8. Plus 1 is negative 7. Okay, negative 1 squared. Negative 1 times negative 1 is positive 1. Negative 2 times positive 1 is negative 2. Plus 1 is negative 1. When I put 0 in, 2 times 0 is 0, plus 1 is positive 1. What happens when I put 1 in? Negative 2 times 1 plus 1 is 2. Okay, negative 2, this will be 2 squared would be 4, so negative 2 times 4 is negative 8, plus 1 is negative 7. Uh-oh, what happened? I've got negative 7 as an output twice. So what does that tell us? Step 1, is it a function? Negative 2, negative 1, 0, 1, 2. Yes, it is a function. Now, is it 1 to 1? Negative 7, negative 1, 1, 2, negative 7 again. It is not 1 to 1. Okay, so we can have functions that are not 1 to 1. The important thing to remember when we're looking at inverses, if it is not 1 to 1, number one, it has got to be a function. Number two, it's got to be 1 to 1. If it is not 1 to 1, there is no inverse. Inverse function. When I think of inverse, I think of the word reverse. A function undoes the operation of the first function. That's what your inverse is. F to the negative 1 power means the inverse of function f. Okay, now it tells you that these are all functions here. So when we find the inverse, that means we're going to swap x and y around. So as I'm looking at the inverse, I've got the point, negative 2, 0. I'm going to switch them around. Negative 2, 0 becomes 0, negative 2. Negative 1, 6 becomes 6, negative 1. 0, negative 4 becomes negative 4, 0. Can you do the other three on your own? Pause the video and see if you can write them out quickly. I hope you tried. Okay, 1, 9 becomes 9, 1. 2, 5 becomes 5, 2. 3, negative 5 becomes negative 5, 3. And that is the inverse. So if it's a set of points, switch your x and y around and you are done. What if it's a graph? You've got points. What do you do with your points? What did we do up here? Okay, 3, 5 becomes 5, 3. Negative 1, 4 becomes 4, negative 1. Negative 3, negative 2 becomes negative 2, negative 3. Those are the 3 points you have to graph. 5, 3, so 1, 2, 3, 4, 5. 1, 2, 3. 4, negative 1. 1, 2, 3, 4. Go down 1. Negative 2, negative 3. Negative 1, negative 2, negative 1, 2, 3. Connect your dots and you're done. So if you've got points, it's fairly easy. All you have to do is to switch the x and y around. If you've got a graph, you take your key points, switch them around, and then connect the dots. If you have a table, you complete it, and then you just switch your x and your g of x around. So I'm going to put in 0. 5 times 0 plus 2. 0 plus 2 is 2. 5 times 1 is 5, plus 2 is 7. 5 times 2 is 10, plus 2 is 12. 5 times 3 is 15, plus 2 is 17. 5 times 4 is 20, plus 2 is 22. Okay, that's your original. It tells you that these are all functions, so you know that you can find that inverse. Just like we did before. Oops, I'm going to make it a little bit bigger, a little bit smoother looking. Okay, start with our headings. I'm still having trouble making them straight lines. Maybe I ought to use my ruler. If this is x, this is g prime of x. Okay. 0, 2. Flip them around. 2, 0. 1, 7. Flip them around. 7, 1. Can you do the next 2? Can you do 2? 2, 12. 12, 2. Can you do 3? 3, 17. 17, 3. 4, 22. 22, 4. Remember, this is g to the negative 1 power. That gives you your prime. Okay, to find the inverses of these one-to-one functions, there's 2 ways you can do it. Number 1, you could think about what you're undoing and then do it that way. Number 2, you can swap x and y around and solve for y. So by swapping x and y around, okay, instead of y, I start with x equals 2y plus 4. Okay, subtract 4 from both sides. X minus 4 is equal to 2y. Divide by 2. So, your y to the negative 1 power is x minus 4 over 2. Okay, what if you want to think this out? You're undoing everything. Okay, I've taken some number. First thing I did was multiply it by 2. Then I added 4. How do I undo the last thing that happened? How do I undo adding 4? Well, I would take x and I would subtract 4. The first thing I did was to multiply by 2. How do I undo multiplying by 2? I divide, and this is your y prime. So you can think it out, or you can do the math. For the next one, the first time we're going to think it out, and then we will actually swap them out and do the math. So for this y prime, I've taken x, multiplied by 3, subtracted 1, and then divided by 4. So the last thing I did was to divide by 4. So the first thing I will do is to multiply by 4. Okay, I've gotten rid of that. I've taken x, I've multiplied by 3, and then I've added 1. So I'm going to take x minus adding 1. X minus 1, the opposite is x plus 1. And that will all be over. Instead of multiplying by 3, I'm going to divide by 3. Okay, how does it look if we swap x and y around and solve? So this becomes x is equal to 3y minus 1 over 4. Multiply by 4. So 4x is equal to 3y minus 1. Okay. I've subtracted 1. I've got to undo that. Add 1 to both sides. 4x plus 1 is equal to 3y. Now I divide both sides by 3. Four x plus 1 over 3 is my inverse. And that's the way you do it. You can think it out, or you can swap x and y around and solve again for y again. The way you do it is the way that you understand it. Most of my students will start out swapping x and y around and solving. Eventually they get to where they can think it out after they've done a few. But the way you do it is how you feel comfortable doing it. I know I'm successful when I can identify functions, one-to-one functions, and their inverses. So one-to-one functions and inverses.